Hi everybody, good day to all y'all. Today we're going to be learning a little bit about matter, exactly what it is and how it's organized. So, what you guys need to do is in our Google Classroom page, there is the Matter Notes 2021, just that's the year, and there are these kind of boxes with some text written in them. Matter is anything that has blank, okay? So what you need to do is when we get to that slide, you need to type in matter is anything that has mass and takes up space. So you would type into your document anything that has mass and takes up space, okay? And then similarly, when we get onto the next slide, you'll fill in these boxes, okay? Sometimes there's just a little bit of text that is both in the notes and in the PowerPoint slides that is important, but I don't necessarily need you to write it down. So you're good to go. But whenever you see something that is in boxes, fill in the information that goes in those boxes. I've added sentence starters to each of these boxes so that you know what information should go in each box. Okay. All right. Without further ado, let's get into our video. So, matter is anything that has mass and takes up space. Classically, we define matter as solids, liquids, and gases, okay? But in truth, there are other ways that matter can exist, non-Newtonian fluids, plasma, and things like that. So a better definition is the fact that matter is anything that has mass and takes up space, anything that has mass and volume. You and I, we're matter, we matter because we take up space and we also have mass. We are made of stuff. Okay. So, one thing that is true with all forms of matter is that matter has properties. Properties are simply things that are used to describe matter. They help us identify matter. They let us know what the difference is between matter. I know that a cup, here, I know that this is a cup because of its cylindrical shape, because of the fact that I can drink out of it, the fact that it can hold liquids. These are all properties that this cup has. Okay. But there are a lot of different properties that exist in nature. And so every single substance that exists in nature has at least one different property from other substances in nature. That's what makes it its own special substance. All right. So, how does matter exist in nature? In its simplest form, matter exists in what we call elements. And there's this wonderful thing called the periodic table of elements, which we're going to spend a lot of time this year talking about. The periodic table of elements basically shows us all of the simplest substances that exist in nature. A great example of an element is something like oxygen. Oxygen is the air that we're currently breathing right now, and it's one of those substances in the periodic table. I can't make oxygen any smaller. I could break it down maybe into its protons and neutrons and electrons, but if I do that, then it loses its properties. So elements are the most fundamental and basic materials that make up our world. Pretty cool. Now, there are things in our universe besides just elements. The other main thing are compounds. See, elements can chemically react together. If I've got hydrogen gas and I've got oxygen gas and I mix it together, they will chemically combine with a little bit of energy. They will chemically combine and form H2O or water. It's just two hydrogen molecules and one oxygen molecule. H2O, water. Okay. Most everything you have ever seen in your entire life is a compound. I would be very surprised if you have ever seen more than a handful of elements. They're very difficult to get on their own because elements like to chemically react and form compounds. That is just how they tend to exist in nature. All of the different substances that make up your cell phone right now, primarily compounds. There's a little bit of gold in there, that's an element, but the wires, the screen, the plastic, all of that is a compound. Now, your screen is actually a mixture of a lot of different compounds. And that's another form of matter, is a mixture. If we have elements and compounds that are mixed together, kind of like in a cell phone, right? All of the stuff is mixed together. All of these elements and compounds are mixed together. We have a mixture because the things that we mix together did not chemically combine. Another great example of this would be sand. There are big rocks and there are small rocks, and they're all mixed together, but the rocks themselves are not chemically combined. The little sand fragments that make up the sand, the granules, the grains, they aren't chemically bound together. They're a mixture. Or Kool-Aid, it's sugar and water mixed together, but they're not chemically combined. Okay. So, how can our matter change? There are two ways matter can change. The first is a physical change. In a physical change, we are changing what a substance looks like. When I rip paper, it's still paper, but it looks different. Now it's got a jaggedy edge to it, but it has the exact same properties as before. Paper is flammable. I can burn this still. Even though I ripped it, it is still flammable. Okay. All right, what's the second way? The second way we can change a substance is through a chemical change. A chemical change is whenever a substance changes its chemical properties, it changes its chemical identity. A new substance is formed. For example, if I was to burn this paper, it would become ash. The paper is flammable. Ash is not flammable. It has new properties. Therefore, it's a new substance. So, there are 4 different indicators of a chemical change. These are really useful because it can be really difficult to tell if a substance has new properties. We can do it, but we have to do more experiments. Indicators are really quick and efficient ways for us to tell if a chemical change is happening, and this is the primary method we're going to use to identify chemical changes. A chemical change occurs whenever there's an unexpected color change. For example, if I took this paper and I burned it, it would suddenly turn into gray ash. White things don't typically become gray. If I've got snow outside on the ground, unless like I add something that's gray to it, the snow is going to continue to be white. It's really not going to have that kind of a color change. If we mix red paint and blue paint and it creates purple paint, right, that's an expected color change. But if we mix something that was red with something that was blue and we got green, that would be unexpected. Whenever we mix things together and fizzing and bubbling happen, that means a gas is being produced. If a gas is being produced, that means a new substance is being produced. Anytime we burn something and flame, light, and heat are produced, that's another indicator of a chemical change. If I was to burn this paper, fire, light, heat would come off of the paper, and that would let us know that a chemical change was happening. The last one is called a precipitate. I'll show you guys an example of a precipitate a little bit later on, but precipitates are basically when you mix 2 liquids together and make a solid. We are primarily going to focus on these 3. I am including this one as well because it is true. However, I'm not going to test you guys on identifying precipitates. This is something that you'll do more in later years of chemistry. I'm just telling you about it now so that you know it exists, that there are a couple other indicators. Okay, but these first 3, they are our primary indicators that we will be using in 9th grade physical science. Okay, so there is a table that we're getting to now in our notes, and it's framed a little bit differently than the notes that I have. We're going to be talking about solids, liquids, and gases, and I just want to show you guys how it works. So I'm asking you guys to write things down about the shape, volume, movement of particles, and just a simple picture. You could copy and paste a picture from the internet. I'm going to say picture/example. So if you just wanted me to give me like an example of a solid, a liquid, or gas, that would also be fine as well. But how exactly does this work? Well, I tell you that a solid has a definite shape, it doesn't change. So in the shape section, there we go. In the shape section, we would write definite shape doesn't change. Okay. In the volume section, we would write, where did it go? Come back. There we go. We would write definite volume doesn't change. And so on and so forth. When we're being asked to describe the movement of particles, we would just write that there's very little movement, the particles vibrate. And then you could either have a picture or an example in the last column. So that's how you fill in that table. It's framed a little differently. Okay. There we go. Now it's a little bit bigger, so it might be easier for you guys to see. Yeah, solid shapes do not change. We can bend them a little bit. For example, we know that this cup is solid, and I can bend the shape of the solid a little bit, but not nearly as much as I can change the shape of a liquid. The volume, right, this cup is going to still take up the exact same amount of space that it always would. The movement of the particles, the individual atoms that make up this cup, they are moving, but they're only vibrating back and forth in a fixed position. They're only moving a little teeny tiny amount, and they're mostly staying in the same place. Cool. So how is a solid different from a liquid? The big difference is that a liquid's shape can change a lot. You've probably got a little bit of saliva in your mouth right now. Go ahead and move that saliva around. Your saliva is a liquid, and you can feel the shape of the saliva changing. Liquid shape can change. If I took water that was in the faucet and I put it in this cup, it would take on the shape of this cup. And if I poured this water into a graduated cylinder or a beaker, the shape of the water would change. If I pour it into a bowl, the shape of the water changes. So water has a shape that can change. Solid shape really doesn't change that much. Volume. The volume of a liquid the volume of a liquid does not change. It has a definite volume. You can't really compress a liquid into a smaller space. You really can't expand a liquid either. If you've got 25 mils of water, it's going to be 25 mils of water. The volume of the water won't change. In terms of movement of particles, the water molecules are freely flowing, and we kind of see that with the water itself, right? The water can be poured. So the particles in the water are moving. In this picture, we see that there's a little bit of space in between our particles as well. That's in part because the particles are moving and other particles haven't quite filled in that space yet. Cool. So how are liquids different from gases? Both liquids and gases can change their shape. Go ahead, take a deep breathful of air and fill up your lungs. When you do that, the air that you breathe in takes on the shape of your lungs. And when you exhale, the air that you exhale starts to take on the shape of the room that you're in. So the shape of a gas changes. And the volume of a gas can change as well. You can take a syringe and fill it with air, and you can compress that air and make it take a smaller amount of space. You can also expand the air. A great example of this would be something like a car tire. We can take a ton of air, an absolute ton, like dozens of liters of air, and fill up a car tire so that it's only a handful of liters of space. There's still a lot of air in there. The mass is higher, but it's taking up a different amount of volume. We can compress and we can expand air. Cool. The other big difference is that a gas has its particles moving much, much, much faster than a liquids or solids. In fact, it is moving faster than pretty much just about any form of matter with the exception of plasma. Plasma is something like a candle's flame or a lightning bolt. But a lot of people consider plasma to simply just be a really hot gas because its shape and volume are also the same as gases. There you go. So why did we spend all of this time talking about the different kinds of matter? Why is this important? Our world and universe are huge. There's a lot of difficult things going on in it, and one of the easiest things we can do is we can organize our universe into these nice and simple little categories because it lets us talk about these things better. See, when I know the differences between solids, liquids, and gases, I can utilize those differences to do some really cool things. I can create car tires that can be expanded and contracted because there's gas inside that. But if I tried to fill up a car tire with a liquid, it wouldn't work. And so just these simple fundamental differences allow us to do really incredible things. It's just that they're so basic, we sometimes forget how useful they are. Plus, it also makes a nice segue into all of the different things we'll be talking about, namely chemical reactions. So physical changes versus chemical changes, the main reason we teach that is because it helps us understand how chemical reactions work. And chemical reactions are really the lifeblood of science. They explain so much. They allow us to do so many cool and crazy and unique things. But that's all for now. I'll see you more later, folks. Have a good one. Bye.